记录时代精神，连接东西方精英翘楚。我是潘磊，这里是英国首都伦敦，欢迎您观看瑞内人物访谈节目。本期节目，我们有幸邀请到来自 Salgado 高级合伙人 Edward Hobbs 先生和总裁 Joe Salgado 先生，为我们从多角度解析国际空间站技术与低轨道宇宙空间商业化的议题。Aerospace 是一家国际空间站商业咨询公司，在意大利、英国和法国均设有办公室，主要为航天部门提供商业和市场情报，为私营公司和宇宙局、宇航局机构提供战略咨询，以合理布局商业化空间太空资产。其敏锐的行业视角为考虑采用国际空间站经济政策和增长战略的公共组织和私营部门提供社会经济价值影响和风险研究。通过 Aerospace 国际空间站的全球合作伙伴网络，无缝隙为客户对接有关国际空间站未来商业机会的技术和战略信息。那接下来，首先我们有请到 Edward 加入到我们的讨论环节。第一个问题是 The first question for Edward, please. How much is space present in our daily lives? 的太空领域和我们的日常生活有什么联系呢？ Edward, please.
Oh, thanks, Renee. And let's just say it's great to be on this channel. Thanks a lot for having us on to answer some of the questions, talk about space. I heard recently that 70% of all businesses have some space-enabled capability. But let's just, before we look at the presence in our daily life, let's just go back to look at historically, space has played a really, really important part in the imaginations of our planet. The space race, arguably, between the US and Russia, putting people or man on the moon. We all followed the Apollo missions. Obviously, recently China as well, in addition to the major global powers that have a huge presence in space. So I think it taps into our collective imagination about what is possible for humanity to do in a completely new frontier. And I think that's why everyone is fascinated with space. We have a huge respect for it as something which is slightly unknown, but it's a new boundary that humans are looking to explore. And that goes to the very nature of of human beings. So, space captures the imagination of the population, but this has changed a lot now. Our everyday lives, just going back now to this idea that 70% of all businesses have some space-enabled capability. The main one you might think is GPS. You know, we have it in my telephone. We use it in cars. Companies like Uber depend on it. It's a huge technology which is space-based, space-enabled, allows so many things to happen in our daily lives. Other areas, for example, this conversation wouldn't be possible without space communications and satellites. We have internet connection. We have the ability to see space imagery and the world from the Earth from space. It does all sorts of things for our daily lives, and it's these number of things that it's doing as part of our daily lives is increasing. Now, when I sit in my car or when I use a computer, I don't necessarily understand how the car works or how the computer is working. Even when I watch television or use the internet. Now, in a way, we've had this passive relationship with technology, and space at the moment we're in this passive acceptance that there are many things on Earth in our daily lives that are enabled by space, but we don't really understand them. Now that's changing. This is changing, and from this moment into the future, we're going to be taking a far more active role in what space is doing and what space can do for us. For example, the Topex Poseidon oceanographic satellite enables us to map the ocean floor, enables us to do lots of very complex and advanced weather monitoring, and that's really important for our daily lives as well. We have television, radio, mobile satellite communications satellites, which are there. We use these things every day, and they're improving, and there are more of them being launched. Scientific instrumentation as well, on the Hubble spacecraft, on the Chandra X-ray Observatory. All of these play into our humans becoming far more active in space. So I think we're really at the beginning of how space is present in our daily life, and in the future this will be increasing even more.
Thank you, Edward. Thank you. So the next question for Jules, please. What are the most exciting new technologies in space? 最令人兴奋的太空领域新技术是什么呢？ Joe, please.
Thank you very much, Renee, and thank you for having us here. We're very excited about sharing our passion and knowledge of space with all the audience. So let me go straight into it. Right now, what's happening in space is very exciting. So there's a high developed technology that is enabling, as Edward was saying, a lot of new activities here on Earth. So there are 4 technologies that I have researched and that I have followed very closely. Number 1, it consists of synthetic aperture radar, or more well known as SAR radars. So basically the difference of any traditional radar to these SAR radars is that they're able to actually take pictures in 2 dimensions of a 3-dimensional object. So the direct application of this type of satellite is very useful for any kind of infrastructure. So let's say a bridge or a construction site. Through this information, we can actually see if there has been movement in the bridge. So to actually make sure that the consistent capability and the structure of that building or that bridge in this case is consistent throughout the years, we can use this kind of information, which in this moment, measuring that from Earth is almost impossible. So that's a very interesting capability. And right now, it's at the moment that we are actually building constellations of these type of satellites. So this is a technology that will enable a huge market here on Earth. The second technology, which is applied to space, is cybersecurity. Right now, the amount of information between the downstream and the upstream, it's increasing by the thousands of tens of gigabytes and terabytes. And right now, we have a problem with that information, keeping it safe. So a lot of applications that are targeting this kind of communication through cybersecurity methods are very important at this moment. And that is very linked to space connectivity, which is the third technology in space that is very exciting right now. And the best example is, of course, the American company SpaceX, which is deploying Starlink. It's a constellation that might be about 30 or 40,000 small satellites on the lower orbit, and that will provide connectivity, high broadband to all the world. Right now, there's 40% of the world without access. That represents $1 billion industry, if not a trillion, close to $1 trillion industry. And that's very important. OneWeb, which is a UK company, is also in that run, but they're not the only ones. And that is very linked to a very specific capability called optic laser communication. So right now we're receiving everything through radio waves, right? All the communication we get from satellites is mainly through radio waves. Well, this is a game changer. Optic laser communication is basically a laser beam that is able to download and upload information at a way higher rate. So to give you an example, right now to receive information from Mars, and again, this is not only for lower orbit, but also lunar and beyond. So right now to get information to from Mars, it takes about weeks, sometimes days, depends on how big the package of information is to get from one place to the other. With this laser optical communication, it will be a matter of hours, the amount of information. And this is very important because we cannot have real-time communication with any probe that is on the moon as of this moment, any probe that is on the moon or in Mars. So you can imagine the capabilities for that. And the last one is in-orbit servicing. Right now, the natural life of any satellite is to have life cycle of any satellite is to be deployed, function, and then die. And by die, I mean re-enter the atmosphere and then disappear. Sometimes they're taken to an orbit called the graveyard orbit, and that's where we put them. But eventually, even within 80 years or 100 years, they will have to come down because of the force of gravity. So right now, there was an American company who demonstrated a very interesting capability, which is called in-orbit servicing. So there was a satellite that it was running low on fuel, and that's very important to move orbits and to also calibrate their systems. And it was about to be removed of their duties to be deorbit. And this company was able to dock in space. So this is the first time that it actually happened in history that two moving objects in space, two satellites, in space were able to dock. And this other satellite that was sent from Earth was carrying fuel. So thanks to that, it was able to extend the life of that communication satellite for 5 more years. So that's extremely important because this is opening a new market opportunity for the space economy. And those 4 are the most important technologies I'm looking forward to. Thank you.
Thank you. Thank you. The next question over to Edward, please. What non-space industry can benefit from those new capabilities, please? 那非太空行业可以从这些新功能中受益吗？ Edward, please.
Thank you. Thank you. Yeah, let's pick up on those 3, the main ones that were spoken about. We have SAR, synthetic aperture radar. We have optical laser communications, and also this idea of in-orbit servicing, which is not per se technology, but it's something which will enable lots of different technologies to happen. Now, I think it's interesting for listeners to understand a bit how these groups of technology are being used in the non-space industry. So I'm going to look at the three important and established ones at the moment. Advances will be happening in the industry based on the new technologies which are being developed. But let's look at the first. Let's look at 3 of them. The first one is agriculture. We have the remote sensing satellites and their ability to let's say monitor changes in soil temperature, rainfall amounts, the climate and weather patterns. Farmers and agri businesses are able to use far more precise methods now. We're calling precision agriculture, which also happens by the use of drones on land, which is a cheaper alternative. But the scale is nothing like what's possible from doing it from space, obviously. Now, so that's a really interesting non-space industry that's benefiting hugely from the capabilities that are being developed in space. So agriculture is a key one. Another one would be the area of disaster management. So we're looking at civil security agencies, United Nations organizations, governments who have to respond to disasters. Now, these could be earthquakes, volcanoes, floods, natural disasters, but also man-made disasters. Let's look at the movement of people and populations, border management, issues of global security, which are very hard to track and have been traditionally in the past. So what we're seeing is the use of satellite imagery, of course, which is now being made available to these governmental organizations and non-government organizations or private companies in new business models where satellite imagery is made available to respond to disasters in a much more precise way. Flooding is a good example, the ability to see in real time levels of water rising or which houses might be affected with flooding, very important element here. Also in other areas for planning and development in poverty-stricken countries where we have issues of urban profiling, which are very important. So the ability to have very high precision satellite imagery, which is really improving with the new technology. It's a very important and growing area for the humanitarian side, let's say. Let's say a last one of interest is, which is a huge industry. It's a huge non-space industry on planet Earth. It's the energy sector. Now you might think, well, how does the energy sector benefit from space and new space technology? But space itself as an arena have been very, very good at generating non-carbon power systems. Right? They've had to do this, and we can learn. The energy sector can learn a huge amount from what's happening in space. For example, thermal control is one area which is very important, and in space experimentation, space entities have been very good at that. We're applying now the knowledge from space into the energy sector. It could be as simple as doing new prospection for oil and gas or pipelines, although that doesn't necessarily feed into an environmentally conscious approach. But you could be doing the same thing for renewable energy as well. So it's proven in space, and it's now the technologies are being applied to traditional industries on Earth.
Thank you, Edward. The next question to Jules, please. What do you mean by commercialization of low Earth orbit? 低地球轨道的商业化意味着什么呢? Jules, please.
Thank you, Renee. And that's a very interesting concept, because what happened right now is that we only have an upstream and then downstream. So basically, we're putting satellites in orbit, low Earth orbit or geostationary orbit, and then benefit from the communication. So it can be optical, like observing how life on Earth is, or measurement. It can be also to measure other kinds of like CO2 levels. So it can have thermal capabilities. So that's all that's vertical, that it's called downstream, upstream. And basically, so that's one way to get revenue from that phenomena we call low Earth orbit. But there's a new one that is happening that is actually creating a private use of that space. And it's enabled thanks to the private space station. So right now, the only human presence we have in low Earth orbit is the International Space Station, which hosts about 6 people at any given time, right? But very recently, there are a lot of efforts for new space stations like China and Russia, which just announced it a few days ago, but also private capsules like Axiom or even Bigelow. Those are companies who are now creating new capsules that will fly or orbit around Earth. And actually, NASA just announced a 400 million contract by the end of this year to support the building of these private space stations. And why is it important to have private space stations and a human presence in low Earth orbit? Well, because on top of upstream and downstream benefits, we can also get experimenting, manufacturing, and in-orbit demonstration. So this actually means it's as clear as it says. Manufacturing, it's actually taking advantage of the microgravity phenomena to build either materials or pieces that, because of that microgravity, or that radiation or that extreme environment of the lower orbit are much more improved, or can be in a better way that can have a direct impact here on Earth. So that's one huge segment, which is manufacturing. The second one is much more tested and proven, which is experiment. And usually that's very much along the life science cycle. We know now that we have grow vegetables in space. We know exactly which vegetables and what seeds, the way they behave, and which ones are more resistant and require less water. So that information, we take it back here down to Earth, and we can grow farms in the middle of the desert thanks to that information. So all the experimentation happening, which, by the way, in COVID times, it's important to mention that it has a huge impact. Pharmaceutical companies use a process called crystal growing. And right now, to create a crystal grow here on Earth of good quality, it goes about, let's say, 400,000 euros. But in space right now, because of the increase of private companies, we can get a perfect crystal growth for 200,000. So that's a direct impact, both in the technology and the balance sheet of the company. So that's what I'm talking about with commercialization of LEO. And the third one, the important other kind of branch for revenue is in-orbit demonstration. So basically, we can replicate certain aspects of that lower orbit here on Earth, like microgravity. We know how to replicate briefly microgravity for a few seconds sometimes. But radiation and extreme environments are usually somewhat harder. And so there's a new processes and new vehicles actually happening right now, like free fly. We call them free flyers. So there are vehicles that are going to be orbiting for about a month or two, and then have a re-entry. So we can carry a lot of payload that can be actually demonstrate their feasibility and their operability right on lower orbit, so we can improve them or be ready to launch. So that's a huge market as well, that all these three, in-orbit demonstration, manufacturing, and experiments, create a new commercialization of low Earth orbit.
Thank you. The next one, over to Edward, please. What are the new market trends, and who are the main players in the so-called space economic? 谁是所谓的太空经济的主要参与者，及其新的市场发展趋势是什么呢 ？Please.
Okay, thank you. Yeah, it's a great question, Renee. Really interesting, and it builds from what Jose was just saying about the this commercialization of low Earth orbit. Let's step back and we'll look at this so-called space economy. People call this new space ecosystem. We call it new space. We define it as anything which is not the traditional space sector. We have launch vehicles, rockets, satellites, and spacecraft sending people up into space, primarily driven by governments. So what's happened? We've had over the last 10 years, let's say, we've had the idea of space tourism as something that's captured the imagination of humans again. So SpaceX, Virgin Galactic, these are two huge companies who've raised huge amounts of money. Richard Branson, Elon Musk, Jeff Bezos as well, all operating to respond initially to government needs about being able to send people or things into space. Now, what happened was the idea of space tourism is wonderful. However, it's a very limited capability. What really happened in this whole conversion or commercialization aspect is the companies figured out a way that they could sell a service to government that massively reduced the cost of sending a payload into space. So these reusable infrastructure for space was suddenly upon us. Now, as that was happening, this relationship between government and industry, traditionally government would say, right, NASA, for example, or the European Space Agency or a national space agency would say we have a potential requirement. We send out an RFI to industry. What is it that industry can do? And industry would then say, oh, we can do this or we can do that. And that would shape the requirement for government. So what's happened now, these new models of doing business have arrived based on capability. So what are companies capable of doing, and how does that reduce the cost of doing something in space? And this is the idea that's driving this new space economy as well. Much lower cost ability to access the benefits of space. Now, and if we just look at some of the main players, let's say, in this new space and where investments are going, Jose had mentioned Axiom. They've raised a huge amount of money. You have entities that have raised money through SPACs, which has become a very popular way of raising money at the moment. Astrospace, Momentous, an organization called Rocket Lab have gone public. There's a new SPAC between Redwire Space and Genesis Park called GNPK. These are raising huge amounts of money. They're responding off the back of this new move into the change of model from the traditional space sector into new space, and driving these new trends forward that Jose had mentioned, such as space as a service, in-orbit servicing, space-to-space applications and business, and the private space stations, which are really going to be a very important feature of the future space-scape.
Thank you, Edward. The last question for Joe, please. What is your prediction for the future of the space mission and their economic benefit, please? 您对未来太空使命及其经济效益有何预测呢？
We believe that, thank you, Renee. We believe so much that space is the next frontier, that we believe that every company is a space company, the same way every company is now a digital company. So we will see that transition, and we will see a space impacting and having a direct B2B, let's say, and B2C behavior, like most of the digital technologies we see today. So that I think is a trend. We do believe that, and we have proof of that. That's the most important thing. Right now, there's a study done by a group of bankers in the US, and they predicted that by 2030 or 2040, depends on which document you read, the industry is going to be worth $1 trillion. Now, let's keep in mind that at this moment, the value of the industry is 500 billion. So how are we going to jump from 500 billion to $1 trillion industry in the next, let's say, 15 to 20 years? Well, it's very interesting what's happened in space that is not common in other industries. What happened in space, and many investors don't know this, is that the capability to scale up is completely exponential. So what we're seeing right now is a lot of companies who manage to demonstrate their technology, and going from a few, let's say, 10 people, they suddenly can jump into a group of 50 people within a month. So, and then just keep growing up. Like the scaling up of the space companies and the space technologies happening very rapidly. So that's where we see a really interesting growth in the revenue stream of these companies. So that's why going to that figure from the 500 to the 1 trillion in this short time, it is completely feasible. The other thing that Edward was mentioned was like the SPACs, which are for all the listeners probably are aware of them, but they're like an American financial instrument to go public, to bring public a company. So at this moment, the first space company that marked the trend was Virgin Galactic. And what is interesting about these SPACs is that for the promoter of the SPAC, they are looking at a minimum $10 value per share. And usually, as soon as they go public, that value just goes up. In the case of Virgin Galactic, it reached a high of $69 per stock, which is never heard of. At this moment, actually, by recent news of Richard Branson downloading some of his shares, it just went down to $23 per share. But that, from an investor's perspective, it's a very interesting opportunity. And the last thing I would like to say about that is that as soon as we see that there is a very infinite space, I mean, it sounds like an overstatement to say that space has a lot of space, but it is true. The capabilities are not limited to low Earth orbit or geostationary orbit. It also goes beyond. Right now, we're thinking about a lunar economy, and I think in the future we're going to be able to think about an asteroid economy where we can extract resources, and a Mars economy. This is, of course, we're not there yet by any chance, by any means, but this is something that we can expect to see. This is a trend. So investing right now in the space sector, I think, is one of the best ideas at the moment.
Thank you. So 再次感谢 Edward 和 Joe 今天做客我们的访谈节目，我们还会为您继续带来国际空间站的相关报道。欢迎您收看本期的瑞内人物访谈，我们下期再会。